Okay, today we're covering Chapter 1, Lesson 4, Proportional and Non-Proportional Relationships. So we have three definitions today: proportional, non-proportional, and equivalent ratios. So go ahead and pause this and take a moment to write these down, please. Okay, I just want you to follow along. Miss Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Complete the table to determine the cost for different numbers of pizzas ordered. So if she orders one pizza, it's going to be $8. If she orders two pizzas at $8 each, it'll be $16. If she orders three pizzas, it'll come to a total of $24. If she orders four pizzas, it'll be $32. And if she orders five pizzas, it'll be $40. For each number of pizzas, fill in the boxes to rate the relationship of the cost and number of pizzas as a ratio in simplest form. So we're taking these numbers and we're turning them into fractions, into ratios. Okay. So 16 over 2, both of those can be divided by 2. So you end up with 8 over 1. 24 over 3 can both be divided by 3. So we're going to simplify that. That becomes 8 over 1. So 32 over what? So we look here. It can be 32 over 4. Both of these can be divided by 4. So we're going to get 8 over 1. And then what over 5? It can be 40 over 5. Both of these can be divided by 5. So we get 8 over 1. So what do you notice about the simplified ratios? So these are our simplified ratios. If you notice, they are equal. They're all the same. Our simplified ratios all equal the exact same thing. So that's what we're going to be looking for today. Is we're going to be creating ratios, simplifying them, and finding out if they're equal or not. When we do that, if our ratios are equal, then it's considered proportional. If they're not equal or not constant, then they're not proportional or non-proportional. So in the pizza example on the previous page, the cost of an order is proportional to the number of pizzas ordered, because all of our fractions end up equaling the same thing. And when they're all equal the same thing, we call them equivalent ratios. Part of the word equal is in the word equivalent, so they are equal. Okay, so equivalent ratios, because they have the same value. Okay, take a moment and copy this down. Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. Okay, if you need more time, please pause this so you have more time. We're going to set up a fraction. Sorry, not a fraction. Before we set up our fraction, we're going to set up a table. So we have the amount he's earned and hours he works. Now I'm just going to plug in information. If he works 1 hour, how much money is he getting paid? He's getting paid $18. What about 2 hours? That's $36. 3 hours is $54. And 4 hours is $72. So now we're going to create our fractions. So this is going to be 18 over 1. 36 over 2, can that be simplified? Yeah, both of these can be divided by 2. And when you do that, you get 18 over 1. 54 over 3 can be simplified to 18 over 1. And 72 over 4 can be simplified to 18 over 1. Okay. So now we look at our simplified fractions. Are they equivalent? Yes, they are. So is the amount of money he earns proportional? Yes, it is. It says explain. Now, if you show me this, then I count this as your explanation, because your work is your explanation in math. If you choose not to show your work, then you need to write a complete sentence that makes sense explaining why this is proportional. But either way, you've got to do this work anyway. You can't tell whether it's proportional or not without setting up your fractions. So you might as well just show your work and get credit for that and have one less thing to do. Okay, at Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at this school proportional to the number of teachers? Explain your reasoning. Okay, so make sure that you copy this down. So we have 48 students. For every 2 teachers. So if I had 1 teacher, how many students would I have? I'd have 24. Is this going to change? No. So the ratio of the students to teachers is going to be constant. Okay, it says at Lakeview Middle School there are 2 homeroom teachers assigned to every 48 students. So there will always be 2 teachers for every 48 students. So that's going to stay constant. So since the ratio is constant, the number of students is proportional to the number of teachers. So yes, this is proportional. Okay, because it's always going to equal, when simplified, it's always going to equal this. Okay, copy this down. Uptown Tickets charges $7 per baseball game ticket, plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Explain. So take a moment and copy this down, please. Okay, so we're going to create a table again. So we have the total cost and the number of tickets purchased. So if she buys, or if someone buys 1 ticket, how much is it going to cost? It's $7 plus a $3 processing fee. So it's going to be $10 for the total cost. How much will it be for 2 tickets? That's going to be $7 per ticket, so 7 times 2 is 14, plus 3 is 17. So what we're doing is we have an equation, $7 times the number of tickets, plus our $3 processing fee. Okay? If you just take your cost for 1 ticket and multiply it by 2, that's the same thing as adding a $6 processing fee. But we only want a 3. So we have to find out how much the tickets cost and then add the processing fee at the end. So for 3 tickets, that's going to be 7 times 3, which is 21, plus our $3 processing fee is 24. And for 4 tickets, that's 7 times 4 is 28, plus our $3 processing fee is 31. So for each number of tickets, we're going to write the relationship of the cost and number of tickets as a ratio in simplest form. So now we're going to create our ratios. So this is going to be 10 over 1. This is 17 over 2, which when we simplify that, that gives us 8.5. 24 over 3 simplifies to 8. And 31 over 4 simplifies to 7.75. So we look at our simplified ratios. Are these equivalent? Since the ratios are not the same, they're not equivalent, this is going to be not proportional. So is the cost of an order proportional to the number of tickets ordered? No. Anytime you are adding something, a processing fee, a delivery charge, anything you have to add on for the order, it will not be proportional. Okay? So that's kind of a little trick that we have there. Anytime you have to add something to your number, it's not going to be proportional. Okay, copy this down. You can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. Okay, so take a moment and write that down, please. So we're going to create a table. So we're comparing the sugar to the mix. And we're going to start off with what we're given. So if we have half a cup of sugar, we're going to have 1 envelope of mix. So if I increase that sugar to 1 cup, for every half a cup we have 1. So now we have 2 half cups. And so we're going to have 2 mixes. If I have 1½ cups of sugar, we need, that's 3 halves total, so we need 3 mixes. And if I have 2 cups of sugar, we're going to need 4 mixes. So let's find out if this is proportional. So if I have 1/2 over 1, what does that simplify to? Well, anything over 1 is whatever the numerator is. So think, what's 5 over 1? That's 5. So 1/2 over 1 is 1/2. You're just dividing by 1, which doesn't change your numerator. Our numerator just happens to be a fraction. Okay, now we have 1 over 2. 1/2 again. Now we have 1½ over 3. So I'm going to bring that up here and work this one out. So let's turn this to an improper fraction. 1 times 2 is 2, plus 1 is 3. So we have 3 halves divided by 3. Now we keep, change, flip. This is on the quiz, so you need to make sure that you know this. Keep our first number, change our sign, flip our second number. Can I reduce anything? Yes. The 3 and the 3 can both be divided by 3. So when I do that, I'm left with 1/2 times 1 over 1, which is equal to 1/2. And our last one, 2/4. Both of these could be divided by 2, so it simplifies to 1/2. So is this proportional? Do our fractions all equal the same? Yes, it's proportional. Okay, at the beginning of the year, Isabel had $120 in the bank. Each week she deposits another $20. Is her account balance proportional to the number of weeks of deposits? Use the table below and explain your reasoning. So pause this and take a moment to write this down. Okay, she starts with $120 in her account. So each week she's going to add $20. So after 1 week, she's going to have $140. After 2 weeks, it'll be $160. And after 3 weeks, it'll be $180. So let's see if these are proportional or not. I'm going to put the money over the weeks. So 140 over 1 is equal to 140. 160 over 2. What's 160 divided by 2? That's 80. And 180 over 3 simplifies to 60. So are these proportional? Do they equal the same thing? No, they don't. So here's a little hint. It is not proportional if One, you start with a balance. Like we did in the last example, we started with a balance of 120. So if we're going to start with a balance, it's not going to be proportional. And two, if you add a fee, like we did in example 2 where we had to add the $3 processing fee per order. Okay? Same thing if you have to add a delivery fee. If it's per order, then it's not going to be proportional. So that should help you figure out if it's going to be proportional or not. Okay, last one. Copy this down. The tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Explain. So go ahead and pause this and take a moment to write it down. Okay, so let's see if this is proportional. So we're going to create our fractions. We have 2/5. That's as simplified as we can get. 4/10. That simplifies to 2/5. And 6/15. Can that be simplified? Yeah, this can be divided by 3. So it equals 2/5. So this one's proportional. So even though we know this one's proportional, we still need to check Gabriel's to see if that's proportional. Because sometimes the book will trick you. Sometimes they'll say which one's proportional, and they both may be proportional. Okay, so we need to create our fractions for Gabriel. So we have 3/5. That can't be simplified, so it's pretty easy. Now we have 4/10. 4/10 can be simplified. They can both be divided by 2, so that's 2/5. So it's not looking good. Let's check our last one. 7/15. That one can't be simplified. So I know looking at my fractions that this one is not proportional. Okay. So which situation represents a proportional relationship between the time spent reading and the number of pages read? Martin's does. And explain. Remember, if you show your work, you show me your fractions, I count that as your explanation. If you choose to not show your work, then you need to write a sentence, a complete sentence that makes sense and explains why this one's proportional and this one's not. Okay, something else to remember. It's important to, even though we see that our first two fractions are the same, always check all of your fractions. Because just because a couple of them are the same doesn't mean all of them are going to be the same. Remember, the book is going to try to trick you. It wants to make sure that you're following through completely with your work. So you may have the first few fractions be equivalent, the last one may not be. So always make sure to follow all the way through with your work to check that. Okay, that's it for this lesson. Thank you.